Hello, welcome to this tutorial continuing the series on Python with PSCAD. Today we'll be looking at simulation sets. Basically, simulation sets allow you to run multiple files at the same time on your computer, depending, of course, on the capabilities of your computer. In my case, these projects take 2.5 seconds, which is pretty short, and the projects are not so aggressive. Depending on the ability of your computer and the parallel capability of your chips, you may want to check that. Regardless, assume I want to use this file and then this one that's a little bit different. And I want to run them at the same time to make some analysis. So what you first need to do is make a new simulation set. I'm just gonna rename it, perhaps. I'm just gonna call it pulse width case per se. Okay. Oh, oops. Okay. And then what you want to do is to include on the project. You can include any of the projects that you have over there. So in my case, it would be this one and this one. Next thing you want to do in my case is to take advantage of the psout capabilities. So right here, I'm going to click on project settings. I'm going to advance an advanced psout file, and I'm just going to call it PWM1. Okay, with the same settings that we discussed last time. And then here, again, same thing. Advanced, and then I'm just gonna call it per se this one, just in case. Just gonna save. Okay, make sure that everything is all set, and then what you want to do is right here, instead of clicking on the normal green button to run, what you want to do is click on right here, and then you can select the simulation sets. If you have more simulation sets, they will appear over here. You can just run one or run all of them, or just, I think, with the control key, select all the simulation sets that you want to run. Regardless, say I just want to run this one. So let's just run it for a second. Okay, seems like it's running both of them at the same time. You see this is status. I think this one ran first than the other one, perhaps because of the components. Alrighty. Next, we'll see on Python. I'll get you there. Alright. Now let's go back to the Python code. So, assuming your simulation sets run without errors, so you can verify by just like making sure that both projects ran. You go to your Python, and what I like to do is get the psout files from the folders. I think we went last time on how, for example, let's say that my project inhibits in this folder. So, for example, your psout files will be, for example, here. It will save on these little subfolders. So, for example, in my case, what I want to do is just copy them over here to the same folder where my Python codes are. So I just, as a string, copy the path and the particular file. So after using the psout file command, what you want to do is you create two objects. You create file1 object for the first file and the second object for the second file. And then see how, for example, right here, where I'm going to start pretty simple, you have this voltage input for this file, and then for the second one. This logic is pretty basic. I covered it on the last video. I just want to make sure that these are done in differences with the previous one. You have to create two objects, and you just have to be very careful. Most of the time, your arrows will be over here on the trace tree. So what you can do is go to Tools, go to the psout reader, and then check out the information that you want. So right here, this is the trace 3. So I'm going to start with the first file, the file that's without the filter, without the boost, without everything. So this is my instantaneous voltage, V1. So if we go back here, I have root, main, V1, and then all of its instances. So in this case, it's root, main, V1, and then here is the trace. That's for this file. For the second file, if we go out to the PSL reader command, we open the second file. We have, again, root, main, but we have different elements. So what I want to open over here is EA4. This represented my instantaneous voltage output. Of course, I have more instances over here. For example, this is the first trace of instantaneous voltage after the filter and after the boost. So basically this one. Now I want to compare this voltage after filtering and after a boost converter with this instantaneous voltage, which is the raw output. So basically I just put them together in a file using the matplotlib. If you want to learn more about how to use the matplotlib, there's tutorials on that go beyond the scope of this tutorial, but basically on my other video I have how you can have two different subplots into the same plot. Here I'm not using that, I'm using both traces on the same plot. So if we run this Python script, oops, give me one sec. No, in fact, let's keep it rolling. So right here, in case this happens to you, first of all, don't panic. What I would do is check out the path. So if we go here, I mean it's the same path. Now the first clue here is that it's running this one. It's not running this one. Why can it be? The solution to this is I have it open on my PSL reader. The computer cannot have the same file on two different programs at the same time. Don't panic. You don't have to do anything here. Just go to the psout reader, close it without closing PSCAD. You don't have to close PSCAD. Clear your terminal. Run it again. There you go. Now, something that I cannot do in PSCAD is intercompare different sets of information. For example, I cannot put in this over here on the same plot, but I can do it on Python, and this is what I have. This was my output without the filtering, and this is my perfect sinusoidal. So assume I want to give a representation of how my filtering worked. I can draw a conclusion from here. You know what? The phase is over. It looks like it's inverted, but it also has a little bit of distortion, but it's not significant. You can do analysis in that case, and you can, for example, make so much cleaner. Plus, right here I have a grid. I have a nice title, legends, and I can control even the time domain. This is done with this X limit option. So basically, what I'm trying to say is use the simulation set to run different files. Of course, this is a very simple PSCAD project. It runs for less than 3 seconds. So you don't have to run it, both of them at the same time if you don't want to. But assume you have a big project that it's for 1 minute and the simulation takes hours. Now, in that case, the simulation set is very helpful, and to analyze that data and to incorporate that data is very helpful using Python. You don't have to go into Excel, you don't have to go into MATLAB, you have everything is already at your disposal. Thank you very much. I hope you enjoy it.